So I thought I should add some video to my work here. So this is the induction proof we're trying to do. And one thing that distracted me for a while, I know I have done these at one point in time, but I don't know where my work is. So um, this is just an infinite geometric series, and that distracted me. I was thinking, well, why do I got to do this? And I couldn't get to work, so I figured, well, let's do an induction proof like they asked me to do. So I showed you the base cases using the one as base zero as the zero case, and that worked. So now we're going to do the inductions part. So I replaced n with k's. Now we're going to do the induction process where we take this old sum. See, there's the old sum. And then we're going to add one more term, and that's where we do the k plus 1. And that has to equal the new sum where we replace k with k plus 1. Okay, then trying the algebra to try and get this to work. So make the left side look like the right side. So, I just, I won't tell you how long I spent with it, a while, not too long, but um, one thing I did to this is I know I mean, I see the two. I guess maybe I only really had to work with those two pieces rather than the all three. But I'll show you what I did because I don't want to stop and redo it all. So what I did is I noticed that this was, I said, well, 2 raised to k plus 1 is the same as 2 to the k times 2 to the 1. Remember, you add exponents when you multiply like bases. So then I was looking at all of them, and I said, okay, so this 2 I want to get a common denominator. So it needs the whole bit, the whole 2 to the k plus 1. This one is got 2 to the k. It just needs to be multiplied by 2 to get the k plus 1, right? And then this one's all set. It's got the denominator. So then this is what I ended up with. So right, so you see how 2 times 2k plus 1, so 2 times 2k plus 1, and there's the 2 times negative 1, and then the 1 from the term that was all set. And then I said, okay, negative 2 plus 1 I can put together. And then I want to make this look like this, where there's a 2 minus that fraction. So I broke this expression out into two fractions. Okay, so I said that you can do that as long as you keep the denominator in each of them. And then there, the 2k plus 1 cancels out. You're left with the 2 and 1 over that. And then lo and behold, that's what I wanted. So that's how I made it work. I mean, maybe there's other ways to do it. That's what worked for me. Not an easy question. The one on the exam isn't this hard.